Hello, this is Shaji Brahman Sharkar. Welcome to my class. Today we'd like to talk about parameterizations. So we are given a situation or scenario, and from that we'd like to construct a set of parametric equations, and from those parametric equations and given the scenario we'd like to answer all these different sorts of interesting questions. So let's dive in. The problem statement says Rupam is walking around the coordinate plane. So we are at a coordinate plane, x and y coordinate plane. At time t is equal to 0, he begins at point 5 comma minus 2, so that's his starting point. He walks in a straight line, so it's a completely straight line towards the point negative 7 comma 6 at a constant speed. So it's a straight line between connecting these 2 points. So this is the starting point, this is the ending point, and it's a straight line connecting these 2 points. And Rupam reaches to the ending point starting from the point 5 comma minus 2. The time it takes for him to reach from 0 second to 8 seconds. So the time it takes is 8 seconds, total time it takes. Now we have to answer all these questions from this given scenario. So we have to give parametric equations for Rupam's coordinates t seconds after he begins walking. So we have to construct parametric equations for Rupam's coordinates x and coordinate y, which means we have to construct 2 equations for Rupam's, one for x coordinate and the other for y coordinate, to find Rupam's location, and then find all times when Rupam is exactly 4 units away from the origin is 0, 0, and Rupam drops his wallet 2 seconds after crossing the y-axis. Where is it? Where is his wallet after 2 seconds? Alright, this looks like a very interesting problem, so let me begin by drawing the xy coordinate and locating the points. So that's x and that's y. And these are the 2 points. So for example, this point is 5 comma minus 2, and this point over here is negative 7 comma 6. These are the 2 points. This is Rupam's starting point, and he's walking into this direction. Right? So he's starting from here going to this point. And the time it takes for Rupam to reach from this point to this point is 8 seconds. Now we have to construct a parametric equation, a set of parametric equations for Rupam to find his location at any point in time. So t seconds after he begins walking. So at any point in time, wherever Rupam is, we should be able to find by using the parametric equations that we'll be constructing now. So let's start with the first part of the problem, which is A. Now over here, the starting point is 5 comma minus 2. So let x0 or x naught is 5 and y naught is negative 2. So I'm just labeling this point as x naught and the second point as y naught. Alright, so that's the starting point. The ending point for Rupam is x1 negative 7 and y1 is equal to 6. So that's from here. Now, what is the difference between the x coordinates? So the difference from starting and ending point on the x coordinate is negative 12. Del x is negative 12, and del y is then going to be 8. The difference between them. So remember, when you find this del x, you have to be careful about the fact that you subtract from the final point. You subtract initial point from the final point. So you subtract negative 7 minus 5. And from here, 6 minus 2. So that gives you 8. So final point minus initial point. That's the way to subtract to find out the del x. Okay. Now the time that it takes, del t, the time that it takes is basically 8 seconds, right? I'm going to write 8. Alright, now we have to construct an equation for Rupam's, coordinates. So in order for us to be able to do that, we have to see this is a straight line, so it should be a straight line equation, right? So using these notations that I introduced for different starting point and ending points, I can write this equation for Rupam. So x is then x coordinate for Rupam would then be x naught plus del x divided by del t times t. So that t is the parameter. We are parameterizing the equation x, and the parameter is t. So we like to find this in terms of t. The parameter should be t because Rupam's coordinate, we are asked to find that in terms of t, coordinates t seconds after he begins walking. Alright, so we would, once we do that, we'll be able to find Rupam's location at any point in time in that straight line. So I'll elaborate on that in a bit. So for y coordinate, y naught plus del y divided by del t times t. Now you just plug in the values. So we have x for x. We found x naught to be 5 plus, for our case, del x is negative 12, and del t, which we found to be 8 times t. And over here, for Rupam, y coordinate for Rupam is y naught is negative 2 plus del y is 8, del t is also 8, right? Great. And then you just simplify it a little bit, so it's going to be 5 minus 3 over 2 times t. That's the x coordinate for Rupam's location, and y coordinate would then be negative 2. So this is 1, so it's going to be plus t only, right? So this gives us the x coordinate and y coordinate for Rupam. So Rupam starts from here. At the starting point, Rupam's x coordinate is 5 minus 2. And then he's traveling along this straight line. And I don't know what his coordinate point is afterwards. But now I know because I have this x coordinate, a parameter equation, parameterized in terms of t. So for example, Rupam after 5 seconds, he's somewhere in here, and I can just plug in the time. Alright, so Rupam actually took altogether 8 seconds. So maybe after 7th second, I might be able to find Rupam somewhere in here. Exactly where to find that, I just plug in the second or time in that equation, and then I get the exact x coordinate and exact y coordinate, and for x and y put together, we'll know Rupam's exact location. That is how it's going to serve us. So we have constructed x and y coordinate for Rupam, which means we are done with the first part of the problem. We have given a parameter equation, x and y coordinate, t seconds after he begins walking. So these are expressed all in terms of t. So after t seconds, Rupam's location is anywhere in between you can find. You just have to replace the value t with something. Now part B, find all times when Rupam is exactly 4 units away from the origin. So 4 units away, this is the origin, this is the origin. So I'm going to write 0, 0. This is the origin. Now I would like to see from this origin at what point or at what time Rupam is exactly 4 units away. So it could be 4 units away from here, he could be 4 units away from here. So it seems like he could be 4 units away. If he's walking along the straight line, he could be 4 units away, not just from this side when he's coming from the beginning point, and even after crossing y-axis, or maybe in between, or maybe after crossing y-axis, he might still be 4 units away. Twice he might be 4 units away from the origin. I'd like to see what are those specific times. Now to find out that specific time, I have to find the distance between Rupam's current location and the origin. So that distance should be equal to 4 units. So let's find out the distance first, and then we'll check whether it's 4 units away or not. So let's try to find the distance between Rupam's location and the origin. Part B. Now, do you remember the distance formula? I'll remind you over here. So distance distance, if you are given 2 points, let's say x1, y1, and x2, y2, these are the 2 points that is given, and then the distance, straight line distance between these 2 points would be x2 minus x1 whole square plus y2 minus y1 whole square, square root, whole under the square root. Now that's the formula for straight line distance. Alright, so now we'd like to find out the distance between Rupam's current location and the origin. So to do that, I would write distance is equal to Rupam's current location is x minus 0, because the x coordinate of the origin is 0, plus y minus 0. Y is Rupam's y coordinate, and the y coordinate of origin is 0. So I'm just using the distance formula, whole thing under the square root. So I'm using this formula basically, and the points are basically over here is the Rupam's x coordinate and y coordinate, and the origin. Now, what is Rupam's x coordinate? So this is x squared, right? Because yeah, this gives you x squared, this gives you y squared. So Rupam's x coordinate is this, and Rupam's y coordinate is this. So this is what we are going to write here, right? So let's write Rupam's x coordinate is going to be 5 minus 3 over 2 times t, whole thing squared, plus this is basically y squared, and the y coordinate for Rupam is this, so I'm going to write negative 2 plus t whole squared, right? And the whole thing will be under the square root, right? Okay, so I can clearly see just a minus b whole squared formula. So I'm gonna apply that formula for this part and also this part, right? So I'm gonna find, after applying the formula, this is what I'm gonna get. So 25 minus 15t plus 9 over 4t squared plus 4 minus 4t plus t squared, whole thing under this square root. Okay, great. Now I can simplify it a little bit. I can go ahead and see that this turns out to be 13 over 4 t squared minus 19t plus 29, whole thing under the square root. Okay, so this is the distance at any point in time, distance between Rupam's current location at any time and the origin. Now, as the question said, we would like to find this distance to be 4 units. So I like to find time, at what times Rupam is exactly 4 units away from the origin. So Rupam is walking along this path, and he might be 4 units away from this direction, and then from this place he might also be 4 units away, somewhere in here. So I might be able to get 2 different locations or 2 different times for Rupam's to have 4 units away, to have his position 4 units away. So to do that, all right, so we found the general distance between Rupam and the origin. Now I can use that and say that I want that distance to be equal to 4 units, because I want Rupam's distance and the Rupam's distance from the origin to be exactly 4 units. Now I'm going to write this minus 19t plus 29, the whole thing square root, is equal to 4. So I want this distance to be 4 units, right? Now if I go ahead and try to solve it, I square both sides. So this square root goes away on this side. So it's going to be this thing under the square root is equal to 4. So square root of 4 is 16. So I can just bring the 16 on the other side. I can clean this up a little bit. So it's going to be 29 minus 16 is going to be 13, right? Now this equation over here, this looks like a quadratic equation, right? So we can apply quadratic formula. So let me remind you what this quadratic equation is. So the quadratic formula that I can use over here. So what is this quadratic formula? So if we have ax squared plus bx plus c is equal to 0, this is a quadratic equation. If I have this, and if I want to find out x, if I want to solve for x, then according to this quadratic equation and using the this is the quadratic formula to solve for x. So negative b plus minus b squared minus 4ac, this thing under the square root, divided by 2a. So this is the quadratic formula we can get. So I can compare this equation with this quadratic equation. So this is my a, and negative 19, this is basically my b, and 13 is c. So I can apply this quadratic formula. Now I can go ahead and solve for t. So t is then going to be negative b, and I have negative 19, so it's going to be 19 plus or minus negative 19 whole squared minus 4, 13 over 4 times 13, whole thing under the square root, divided by 2a, which means 2, and our a in this case is 13 over 4. So I'm going to write 13 over 4. Alright, so I can solve this using a calculator, and the way we like to solve it is in two cases. We have two cases here. In the first case, we consider only plus and we ignore minus totally. Only on this case, not anywhere else. Only on this place, we consider, in the first case, we consider only plus and compute. And in the second case, we ignore plus but consider only minus and then compute. So I get two cases, and two cases generates two different results. So after calculation, what I'm getting is 0.791. That's one of the results. The other result that I'm getting is 5.055 seconds. So these are the two results that I'm getting. And it's obvious why we are getting two results. Like I said in the beginning, that we might have two cases where Rupam would be 4 units away. So one could be somewhere in here. I'm just arbitrarily labeling it. One could be somewhere in here, and the distance might be 4 units. So 2 points in time. So these are the 2 points I've found. T, I have two values of t, and this is obvious why we're getting it, right? So that answers our second question that says find all the times. We have found 2 times. At 2 different times, Rupam can be exactly 4 units away from this origin. Now, third part of this problem says Rupam drops his wallet 2 seconds after crossing the y-axis. Where is it? This is the y-axis we have, right? So Rupam starts from here. After coming all the way up to here, he's crossing the y-axis over here at this point, right? And he drops his wallet 2 seconds after that. Maybe, I don't know, somewhere in here, okay? So 2 seconds, after 2 seconds, somewhere in here, let's say, 2 seconds, he drops his wallet. So Rupam is crossing the y-axis when the x value is 0. At this point, x is equal to 0. So this is the point where Rupam is crossing the y-axis. And after crossing the y-axis, 2 seconds later, probably in here, Rupam drops his wallet. Where is it? So this is where he drops his wallet. So his wallet should be here, right? So this is what we'd like to find out. So in order to do that, we're going to use the idea where we can actually use this x equal to 0. So we have to see Rupam's x coordinate, right? And we can find that from this equation we have found, right? This parametric equation, x equal to 5 minus 3 over 2 times t. On this equation, if we plug in x equal to 0, then we get Rupam's location when he's crossing the y-axis, right? So we can go ahead and start working on part C of this problem, part C. So this is part C. So when does he cross the y-axis? So I'm going to write, when does he cross the y-axis? Alright, so I said that we're going to be using the Rupam's x-coordinate parametric equation for his x-coordinate. So this is the x-coordinate for Rupam, and it's a parametric equation. And we saw that from the graph, we just saw that he's crossing the y-axis when his x-coordinate is 0. This is where. So I can use this idea now, and I can write that this is equal to 0. So the value of x is equal to 0 at this point. And this is where he is basically crossing the y-axis. So the time, we solve it for t, and then we get 10 over 3. So this is the time that we get when he is crossing y-axis. Now he drops his wallet, not at y-axis, but after 2 seconds. So 2 seconds later, 2 seconds after crossing the y-axis, he's dropping his wallet, right? So the time after 2 seconds, 2 seconds later, so 2 seconds later, what I get, the time that I have right now is t is equal to 10 divided by 3. This is the time, and I'm going to add 2 seconds to that. So then the time t would become 16 over 3. So at 16 over 3 seconds, at this time, he's going to drop his wallet. Now, where he's exactly dropping his wallet? We have found that after 2 seconds, we have found the time, so exact time, which is 16 over 3. Exactly 16 over 3 at that second, he is dropping his wallet. But where is this location? What is this location? I like to know. So how can I find Rupam's location at a specific time? And we know we have constructed the parametric equations for Rupam's coordinate. That's a general one. And if I plug in a specific time, then I find his specific location at that time. And these are the parametric equations we have found for Rupam from the problem part A. So these are the set of equations we'll be using now. So I can go ahead and in place of time t, I'm going to replace the time when he drops his wallet. So the time that we found is 16 over 3. I'm just going to plug 16 over 3 in place of t, and I'm going to find the x-coordinate and y-coordinate of Rupam, which means that I'll be able to find Rupam's exact location when he drops his wallet. So now I know when he drops his wallet. Now I would like to know where he drops his wallet, and this will give me the location. So these are the two equations now we're going to use. Now this is the time when he drops his wallet. Now I would like to know where he drops his wallet. Where is he then? Where is he at that time? So his location. So the equation, the parameter equation that we got from part A of this problem, we can just plug in this time in it. So the equation that we got is 5x equal to 5 minus 3 over 2 times t. So this is my t. I'm just going to plug in t over here, right? And then that gives me negative 3. You can just calculate that. And the y-coordinate of Rupam, so negative 2 plus and -2 plus t. So the time t is 16 over 3. So that gives me 10 over 3. That is the location where Rupam is at time t is equal to 16 over 3. Now I know where he is at that time, and that is where he drops his wallet. So the wallet is at, so where is it? It's at the coordinate x and y, which is -3, comma 10 over 3. This is where he drops his wallet. So to sum it up quickly, so we found out Rupam's set of parametric equations to indicate his location at any point in time from part A. From part B, I found that there are two different times when Rupam is exactly 4 units away. I calculated using the distance and the unit 4, and then I found that Rupam drops his wallet 2 seconds after crossing the y-axis. So we found the time when he drops, and then I used that time and plugged this into the parametric equations that I found from part A to find his location, x and y coordinate, basically x and y coordinate of Rupam's location at any point in time. I plug in a certain time that gives me the exact location of Rupam at a certain time, and then I know that is where he drops his wallet, and I know where he drops his wallet now, and I figured out the coordinate point for his wallet at that time. So that's great. Everything checks out, and we have discussed about the parameterization, and we solved this problem. Thank you very much. See you in the next lecture.